Now take this question from mathematical induction. By using mathematical induction, show that for all n belongs to n, 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus so on up to 1 by 2n minus 1 into 2n plus 1 is equal to n by 2n plus 1. So over here you can see nth term is given in the question. So we don't have to find it. So directly we will start with the statement. So let S of n be the statement that S of n is equal to 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus so on up to 1 by 2n minus 1 into 2n plus 1 is equal to n by 2n plus 1. Now we will start with the step 1. What will be the first step? To show that S of n is true for n is equal to 1. So first we will take LHS. In LHS we need to take nth term. So what is nth term? 1 by 2n minus 1 into 2n plus 1. Now put n is equal to 1. So 2 into 1 minus 1 into 2 into 1 plus 1. So that is 1 by 2 minus 1 is 1 and 2 plus 1 is 3. So LHS is 1 by 3. Now the same way we need to take RHS. RHS is n by 2n plus 1. So put n is equal to 1. You will get 1 by 2 into 1 plus 1. That is 1 by 3. So LHS is equal to RHS. Therefore, S of n is true for n is equal to 1. So the first step is completed. Now let's move on to step 2. So what is step 2? We need to assume that S of n is true for n is equal to k. So in the statement, in the place of n, we need to write k. So S of k is equal to 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus so on up to 1 by 2k minus 1 into 2k plus 1 is equal to k by 2k plus 1. Take this as equation number 1. Now moving on to step 3. In step 3, we need to show that S of n is true for n is equal to k plus 1. So what do we have to do? Take the rough column. Now write the nth term. Nth term is 1 by 2n minus 1 into 2n plus 1. Now wherever you have n, you put k plus 1. So 2 into k plus 1 minus 1. This is one bracket. And in the other bracket, 2 into k plus 1 plus 1. So that will be 1 by 2k plus 2 minus 1. And then 2k plus 2 plus 1. So what will be the, I'm just writing it over here. I don't have space there. So that is 1 by 2k plus 1 into 2k plus 3. So this is the value with which we have to add on both sides. So adding 1 by 2k plus 1 into 2k plus 3 on both sides of equation number 1. So what do we get here? 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus so on up to 1 by 2k minus 1 into 2k plus 1 plus 1 by 2k plus 1 into 2k plus 3. That is equal to k by 2k plus 1 plus 1 by 2k plus 1 into 2k plus 3. Now we have to solve this RHS further. Now we need to further simplify. So we need to take LCM here. Tell me how to take the LCM. So LCM is 2k plus 1 into 2k plus 3. Now in the first term denominator, you have 2k plus 1. You don't have 2k plus 3. So numerator multiply with 2k plus 3. So k into 2k plus 3. And in the second term denominator, you have both the terms. So we write the numerator as it is. Now we need to open the brackets, that is multiply k with the first bracket. So that is 2k square plus 3k plus 1 by 2k plus 1 into 2k plus 3. Now in the numerator, we need to split the middle term. So how do we split the middle term? 3k we can write it as 2k square plus 2k plus k plus 1 by 2k plus 1 into 2k plus 3. So if we take 2k common, we get k plus 1. And if we take 1 common, we get k plus 1 by 2k plus 1 into 2k plus 3. Now we need to take k plus 1 common. So we get k plus 1 into remaining terms you write in one more bracket. 2k plus 1 by 2k plus 1 into 2k plus 3. So 2k plus 1 get cancelled. You get k plus 1 by 2k plus 3. But still we did not get the RHS. So what I will do is, denominator I will write 2k plus 3, I will write 2 plus 1. Now from the denominator, if I take 2 common, we get k plus 1 plus 1. Now you check the RHS of the question. Wherever you have n, you got k plus 1. So in the RHS, you have n by 2n plus 1. So in the place of n, we got k plus 1. So we can write, therefore, S of n is true for n is equal to k plus 1. Finally, we need to conclude. Hence, by the principle of mathematical induction, S of n is true for all n belongs to n. Now take this next question. This is same like the last one, but the difference is in the last problem, nth term was given in the question. But over here, nth term we have to find out. So first let us start with finding the nth term. So first we need to put the side heading to find nth term. So in the denominator, you have two terms in each term, two numbers in each term in the denominator. So first let us take the first number. So we take 1, 4 and 7. So 1, 4, 7, so on are in AP. So A is equal to 1, D is equal to 4 minus 1, that is equal to 3. So nth term formula is A plus n minus 1 into D. That is 1 plus n minus 1 into 3. That is 1 plus 3n minus 3. That is 3n minus 2. Now we take the second number 4, 7 and 10. So 4, 7, 10, so on are in AP. So A is equal to 4, D is equal to 7 minus 4, that is 3. Now we write the nth term formula, A plus n minus 1 into D. That is 4 plus n minus 1 into 3. That is 4 plus 3n minus 3, which is equal to 3n plus 1. So we get the nth term over here. Nth term is, now we don't just multiply. See the question, you have 1 by 1 into 4, 1 by 4 into 7. So nth term is 1 by the first nth term into the second nth term. So this is the final nth term we have got. Now after finding the nth term, we need to write the statement. So let S of n be the statement that S of n is equal to 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 plus so on up to 1 by 3n minus 2 into 3n plus 1 is equal to n by 3n plus 1. This is the statement. Now we will start with the step 1. So what is the step 1? To show that S of n is true for n is equal to 1. So take the LHS. 1 by 3n minus 2 into 3n plus 1. So put n is equal to 1. 3 into 1 minus 2 into 3 into 1 plus 1. So that is 1 by 3 minus 2 is 1 and 3 plus 1 is 4. That is 1 by 4. So RHS is n by 3n plus 1. Now put n is equal to 1. So you get 1 by 3 into 1 plus 1. So that is 1 by 4. So you can see we got LHS and RHS same. So we write LHS is equal to RHS. Therefore, S of n is true for n is equal to 1. So we are done with first step. Now we shall move on to step 2. So step 2 is assume that S of n is true for n is equal to k. So 1 by 1 into 4, S of k is equal to 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 plus so on up to 1 by 3k minus 2 into 3k plus 1 is equal to k by 3k plus 1. This is equation number 1. Now step 3. To show that S of n is true for n is equal to k plus 1. So we need to take the rough column, and again, like how we have done in every problem, we have to do that. First take the nth term. So 1 by 3n minus 2 into 3n plus 1. Now put n is equal to k plus 1. 3 into k plus 1 minus 2 in one bracket. Then 3 into k plus 1 in the second bracket. So 1 by 3k plus 3 minus 2 into 3k plus 3 plus 1. So that is 1 by 3k plus 1 into 3k plus 4. This is the k plus 1th term with which we need to add on both sides. So adding 1 by 3k plus 1 into 3k plus 4 on both sides of equation number 1. So we get 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 plus so on up to 1 by 3k minus 2 into 3k plus 1 plus 1 by 3k plus 1 into 3k plus 4 is equal to k by 3k plus 1 plus 1 by 3k plus 1 into 3k plus 4. Now we need to take the, see this is 3k plus 4. Now we need to take the RHS and take the LCM. So 3k plus 1 into 3k plus 4 is the LCM. So in the first term in the denominator you have 3k plus 1. You don't have 3k plus 4. So we need to multiply the numerator with 3k plus 4. So k into 3k plus 4 plus 1. Now you see how we simplify further. So this into this into this. So 3k square plus 4k plus 1 by 3k plus 1 into 3k plus 4. So that is equal to, now we need to split the middle term. So how do we split the middle term? 4k we can write it as 3k plus k. And the denominator we write as it is. Now we take 3k common, so we get k plus 1. Then 1 common, again we get k plus 1. Denominator is 3k plus 1 into 3k plus 4. Now again, both the brackets are same in the numerator. So we need to take that common. That is, we write that in one bracket. So k plus 1 into the remaining terms in another bracket. By denominator is as it is. Now numerator and denominator, we can cancel this term. So we are left over with k plus 1 by 3k plus 4. But still we did not get the RHS of the question. So that is k plus 1 by 3k plus 4 we can write as 3 plus 1. So k plus 1 by, if I take 3 common, k plus 1 plus 1. Now you can see the RHS of the question. Wherever you have n, we got k plus 1. So finally we can conclude, therefore, S of n is true for n is equal to k plus 1. Hence, by the principle of mathematical induction, S of n is true for all n belongs to n. Now take the next question. This is also very important. By using mathematical induction, show that for all n belongs to n, a plus d plus a plus 2d plus so on up to n terms is n by 2 into 2a plus n minus 1 into d. So as you can see, this is the LHS itself is in AP. This is the general form of AP. And right hand side is sum to n terms of AP. Okay, so directly we will get the nth term here. So because up to n terms is given, as usual, we will find out the nth term. So first put the side heading to find nth term. And you will get the nth term directly here. So what is nth term in nth term of AP? That is a plus n minus 1 into d. So this is the nth term. Now let S of n be the statement. Let S of n be the statement that S of n is equal to a plus d plus a plus 2d plus so on up to a plus n minus 1 into d is equal to n by 2 into 2a plus n minus 1 into d. Now first let us take step 1. What is step 1? To show that S of n is true for n is equal to 1. So we will take LHS here. LHS is a plus n minus 1 into d. Now you put n is equal to 1. So that will be a plus 1 minus 1 into d. So that is a plus 0d. 0 into anything is 0. So that is a plus 0, which is equal to a. So you got LHS as a. Now let us take RHS. RHS is n by 2 into 2a plus n minus 1 into d. Now over here you put n is equal to 1. That is 1 by 2 into 2a plus 1 minus 1 into d. So that is 1 by 2 into 2a plus 1 minus 1 is 0d. Again 0 into anything becomes 0. So 2a plus 0. Now here 2 and 2 cancel, that is a. So LHS is equal to RHS. Therefore, S of n is true for n is equal to 1. So with this, our step 1 is completed. Now we need to start step 2. So what is step 2? Assume that S of n is true for n is equal to k. So S of k is equal to a plus d plus a plus 2d plus so on up to a plus k minus 1 into d is equal to k by 2 into 2a plus k minus 1 into d. So now we move on to step 3 and we take this as equation number 1. So what is step 3? To show that S of n is true for n is equal to k plus 1. So again in rough column we need to take the nth term. Nth term is a plus n minus 1 into d. So in the place of n we take k plus 1. So k plus 1 minus 1 into d. Plus 1 minus 1 cancel, you get a plus kd. So this is the term with which we are going to add now. So adding a plus kd on both sides of equation number 1. So you get a plus d plus a plus 2d plus so on up to a plus k minus 1 into d plus a plus kd is equal to k by 2 into 2a plus k minus 1 into d plus a plus kd. Now only take the RHS. Now we take the LCM here, 2 into k into 2a plus k minus 1 into d plus 2a plus 2kd whole divided by 2. Now that is 2ak plus k into k minus 1 into d plus 2a plus 2kd by 2. So now we need to simplify further. 2ak plus, now this is kd. kd into k is k square d plus, minus kd into 1 is kd plus 2a plus 2kd by 2. Now 2kd minus kd is kd. So 2ak plus k square d plus 2a plus kd by 2. Now that is from these two terms, if I take 2a common, we get k plus 1. And from these two terms, if we take kd, we will get k plus 1 by 2. Again k plus 1 in one bracket and then 2a plus kd in another bracket by 2. Now over here, but still we did not get the RHS of the question. So what do we have to do here? So that is equal to k plus 1 by 2 I am writing separately, and over here 2a plus this kd I will write k, I am adding and subtracting 1 here to this k. Now you can see the question, wherever you have n you got k plus 1. So you got n by 2 into 2a plus n minus 1 into d. So therefore S of n is true for n is equal to k plus 1. Hence, by the principle of mathematical induction, S of n is true for all n belongs to n. Take the next question. By using mathematical induction, show that for all n belongs to n, a plus ar square plus so on up to n terms is equal to a into r power n minus 1 by r minus 1. So over here you can see this is the general form of GP. Okay, because you have R stands for common ratio. So whenever you have common ratio, it is GP. Whenever you have common difference, it is AP. Okay, so first we need to find out the nth term. So write the side heading to find the nth term. So directly we can take the nth term here. Nth term of GP is AR power n minus 1. Now directly we got the nth term. So we will start with the statement. Let S of n be the statement that S of n is equal to a plus ar square plus so on up to ar power n minus 1 is equal to A into r power n by r minus 1. Now we will start with step 1. Step 1 is to show that S of n is true for n is equal to 1. So first we will take LHS. In LHS we need to take nth term. Nth term is AR power n minus 1. So if you put n is equal to 1, you will get AR power 1 minus 1, that is AR power 0. But we know that anything to the power 0 is 1. So A into 1, that is A. So we got LHS as A. Now we take RHS. RHS is A into R power n minus 1 by R minus 1. So put n is equal to 1. So you get A into R power 1 minus 1 by R minus 1. So that is A into R minus 1 by R minus 1. Both get cancelled, that is A. So LHS is equal to RHS. Therefore, S of n is true for n is equal to 1. So we got the step 1. Now, step 2 is assume that S of n is true for n is equal to k. So we write the whole statement again by replacing n with k. So S of k is equal to a plus ar square plus so on up to ar power n minus 1, sorry, k minus 1 equals a into r power k minus 1 by r minus 1. This is equation number 1. Now step 3. Step 3 is to show that S of n is true for n is equal to k plus 1. Again take the rough column. In rough column you first write the nth term ar power n minus 1. Now in the place of n you put k plus 1. So k plus 1 minus 1 plus 1 minus 1 cancel, that is ar power k. Now we need to add ar power k on both sides. So that is a plus ar square plus so on up to ar power k minus 1 plus ar power k is equal to a into r power k minus 1 by r minus 1 plus ar power k. Now you take LCM. LCM is r minus 1. So multiply this into this into this. ar power k minus a plus you multiply r with ar power k. So you get ar power k plus 1 minus 1 into ar power k is ar power k. So ar power k get cancelled. I am erasing this rough part. Now if I take a common, we get r power k plus 1 minus 1 by r minus 1. Now you can see the RHS of the question. In the RHS of the question, wherever you have n, we got k plus 1. So finally we can say therefore S of n is true for n is equal to k plus 1. So hence by the principle of mathematical induction, S of n is true for all n belongs to n.